Hey, welcome! Have you ever stopped to think about the hidden math in the world all around you? Well, today we're going to do just that. We're going on a little geometric adventure to uncover the math hidden inside the stuff you see every single day. I mean, really think about it for a second. That Amazon package on your doorstep, the cereal box in the kitchen, heck, even the room you're sitting in right now. The answers to these questions are kind of locked away inside their dimensions, and today we're going to find the keys. And the main key is understanding shapes, just like this one, the good old cuboid. Yeah, it looks pretty basic, but it is an absolute powerhouse of geometric secrets that help us measure, build, and just make sense of the space we live in. Okay, so to start cracking these codes, first we need to build ourselves a mathematical toolbox. And don't worry, these aren't super complicated theories. They're actually simple, powerful ideas that are the bedrock for everything we're about to do. First tool in the box, the idea of a solid. And look, it's just a fancy name for any three-dimensional object. If you can hold it, touch it, and measure it, yep, you're dealing with a solid. Simple as that. Now for our first big tool. Let's talk about volume. This is the one that answers the question, so how much can it hold? Think of it like the amount of coffee you can pour into a mug or how much stuff you can cram into a suitcase. It's all about the space inside. And the second big tool for our kit, surface area. This answers our other question. How much wrapping paper do I need? See, this isn't about what's inside. It's the total area of the object's outer skin. It's the part you can actually touch or paint. So here's the absolute key takeaway, the thing you've got to remember. Volume is all about the inside, the capacity, and we measure it in cubic units. Surface area is all about the outside, the covering, and we measure that in square units. Inside versus outside. Nailing that difference is everything. All right, basics are down. We've got our toolbox. Now let's pull out some specialized gear. For this explainer, we're going to zero in on two of the most common and honestly most useful solids you'll ever run into, the cuboid and the cube. First up, we've got the cuboid. And honestly, you see this thing everywhere. It's your classic rectangular box, and it's defined by three simple measurements. Its length, its breadth, or you can call that width, and its height. Most rooms, books, even bricks are cuboids. And check this out. Here are these simple formulas that unlock all its secrets. Volume, just multiply length times breadth times height. Easy. Total surface area adds up all six faces. Oh, and that lateral surface area, that's a cool one. Just imagine painting the four walls of a room but leaving the floor and the ceiling alone. That's it. Next, meet the cube. It's kind of like the cuboid's super perfect cousin. So what makes it so special? Every single edge, the length, the breadth, the height, they're all exactly the same. Think of a single die or a sugar cube. Perfect. And because all the edges, which we'll just call A, are equal, well, the math just gets so much cleaner, so much simpler. The volume is just A to the power of 3. And the total surface area, that's just the area of one face, A squared, times the 6 faces it has. It's so much more streamlined. Okay, our toolbox is packed. We've got our special gear. You know what that means. It's time for the really fun part. Let's put these tools to work and solve some real-world puzzles. So here's puzzle number 1. Picture this. You've got a solid little cube of metal. You toss it into a furnace, melt it all down, and then pour that liquid metal into a mold that makes a long, skinny, rectangular bar, a cuboid. The shape is totally different, so what's its new height? Okay, the key, the whole secret to solving this puzzle is this one simple idea from physics. When you melt something down and reshape it, you're changing its length, its surface area, pretty much everything, except for the actual amount of stuff it's made of, the volume. The volume stays exactly the same. So here's our game plan, step by step. First, we use our handy cube formula to figure out the volume of metal we're starting with. Then we take the cuboid volume formula, plug in the numbers we do know, and set it equal to that original volume. After that, all that's left is to solve for our unknown h. And there it is. Our answer is 100 centimeters. Can you believe that? That little 5-centimeter cube turns into a bar a full meter high. This is such a great example of how volume stays constant, no matter how wild the shape gets. All right, that was cool, but let's go big for our next puzzle. We're moving from a tiny metal cube to a full-on construction project. We need to build a massive wall, and we know the size of our standard bricks. So the big question is, how many will it take? Now, before we even touch a number, let's get a picture of what we're actually doing here. We have one giant cuboid, that's the wall, and our job is to fill it up completely with thousands of tiny little cuboids, our bricks. The logic here is all about volume. You know, the actual plan here is surprisingly simple. All we're really asking is, how many little brick-sized volumes can we fit into the huge wall-sized volume? So it's just a division problem. The only tricky part is you have to be super careful to make sure all your units are the same before you start. So what's the final count? Get this, a whopping 15,000 bricks. I mean, that's the power of having the right tools in your math toolbox, right? You can go from a thought experiment to planning a major building project. And hey, here's one last really cool tip for you. Remember that formula for the diagonal of a cuboid? It's not just some random line. It actually tells you the absolute longest, straightest objects, like a fishing rod or a curtain pole, that you could possibly fit inside a box or a room. It's like the ultimate packing hack. So, as we finish up here, I want you to do something. Just look around the room you're in right now. Chances are, it's a cuboid. Now, if you wanted to repaint just the walls, which tool from our toolbox would you need to figure out the area you need to cover? Would it be total surface area or lateral surface area? See, the answer is right there in front of you.